let's talk about one central problem that's plaguing physics for the last 30, 40, or even more than that years, which is the problem or the search for this elusive theory of everything. So let's introduce this topic. What are grand unified theories? And then what is a theory of everything? What is the problem we're trying to solve? What are we trying to unify?
Okay, so what happened? So when I, so I went to college. I went to Harvard College in 1975, and that was a period, and started studying the physics department there. That was a period that was just 2 years after kind of this huge set of breakthroughs, which culminated in 1973 in something which is now called the Standard Model. So there's this kind of beautiful mathematical structure called the Standard Model. It was developed throughout the 60s and kind of came together in 1973, and it just does an amazing job. It does too good a job of kind of explaining everything about what particles do. So everything that we see when we study particle interactions, and no matter how high in energy you collide them at a collider or whatever experiment you do to any accuracy, this theory describes it perfectly. And it, and so it was, a lot of the people who had been responsible for developing it were at Harvard, and it was this huge kind of era of triumph there. All this new data was pouring in, which agreed perfectly with the theory. And so, some of the great people who had been like Glashow and Weinberg, and who'd been working on this for the last decade, they were being kind of completely vindicated, and it was an amazing time. And then, but there was actually kind of an ambitious idea around the same time. It literally, a year or two after the Standard Model first came in 1973, around the same time, there was also beginnings of attempts to kind of further unify, to take the Standard Model has a few different pieces in it, and the idea was to try to find some kind of way to fit those pieces together into something which would be, in principle, explain a bit more and predict a bit more than the Standard Model. Mm-hmm. And that was what these so-called grand unified theories. And actually, it was people at Harvard who were the main people doing this, Howard Georgi and Shelley Glashow. And that, so these are called grand unified theories, and it's really an attempt to do better than the Standard Model, and to have more unification, to unify like the strong and the weak interactions together. And so that's grand unified theories. The other big open question then remains is what to do about gravity. So besides the Standard Model, you have a very good theory of gravity, how gravity works, due to Einstein from early in the 20th century, and that theory has some intriguing relations to the Standard Model. It uses some of the same geometry, but it has, if you try and treat it the same way as the Standard Model, and you try and quantize it the same way, that you get into technical problems, and so that was kind of the other big open problem is what about getting a consistent quantum theory of gravity, and then the hope was that you could maybe solve both of these problems. You could get a grand unified theory and also one that included an explanation of gravity, and that's the sort of thing that people would often call kind of a theory of everything. Because at that point, you brought together all of the known kind of fundamental theories we have in physics. But so it's I think somewhat of a joke to call it that. But that's anyway, that's what people typically mean by that.